it looks really fun, so I thought I'd dive into that one.
You don't rest.
Yeah.
You're on to the next one already.
Yeah, but like I was like, because the CommonLit one I think it took about 8 days for the leaderboard to finalize, and I was like, oh, please finalize the leaderboard. You know, when you're in that little in-between zone, it's like, oh, they're not finalizing the leaderboard. So I thought, okay, I'll settle the nerves a bit by starting a new competition.
That's awesome. Is that how we settle our nerves? That's crazy.
That's a sign of a true addiction, isn't it?
Yeah. I remember when our team got we were eighth originally on the Pet Finder, and the leaderboard was saying that it's going to finalize. I was just like sure that we're going to drop down. Like
Yeah.
this can't
There's
happen.
going to be something that happens, right? Until it's finalized. Obviously, like it's very rare that something happens, but yeah, it's just this, and it was like 8 days. It's like, okay, I just need to start a new competition and just not think about this anymore.
No, but I was like really happy to see your name. I saw the the dinosaur there, and I was like thinking, is this Anjum? Oh no way, that's awesome. Yeah.
Yeah, because I wasn't initially planning to do it solo, but because I was on holidays for like the last part of the competition, I didn't really want to team up with someone and then go away, because that's not really fair on the teammates. So I thought, okay, I'll see if I can do it solo, and it seems to work out okay in the end.
And you got the gold medal. The hardest thing on Kaggle.
Yeah, so I was pretty happy with that.
No, that was incredible. We have a few people in already. Guys, we're just chatting with Anjum. We get to start, so feel free to say hello if you'd like. I'm just catching up with Anjum. We've been friends for a long time on Kaggle. What hardware are you rocking right now? Did you get the 3090?
Yeah, so I managed to get I managed to get two 3090s in the end.
That's awesome.
So in the UK there was shortage everywhere, and I was checking there's one main importer for 3090s, and they were selling them brand new, and the prices were just going up and up and up. And then eventually I said, well, I'll just get one off eBay from one of the scalpers. I didn't really want to give a scalper money, but it was still cheaper than what it was brand new from the other website.
That's crazy.
And the prices were just going in one direction. So I managed to get two Founders Edition cards.
Do they work nicely? Like, what case are you using? I'm just curious.
So I think I've got like I don't know what it is. It's a Logitech D750. It's quite an old one. A lot of bits of my computer. It's a bit of a Frankenstein computer from previous computers.
Right. That's how it is, right?
Yeah, it's good. It's good to carry over bits and pieces. But in fact, the first computer I bought for Kaggle was actually like a second-hand computer. It was an old HP workstation.
Okay.
And they're super cool, the HP workstations. And then I moved to the Middle East. I was living in Kuwait for a while, and the power supply died. And in these HP workstations, everything is custom inside, and there was no chance of me.
You can't buy those parts.
Yeah, and I took it to a random guy in the market, and he said, "Oh, maybe I can fix it, maybe I can't," and couldn't fix the power supply. So I had to just build a new computer out there, and then. So
I mean, that kind of worked out for the best in a way.
Yeah. Secretly, I wanted to build one.
Yeah.
So that was cool.
That's awesome.
Yeah. So I'm in this little room where my computer lives, and it gets very hot. So normally have to keep this.
Tell me about it.
Yeah. And my wife is like, "Oh, you're burning so much electricity." And now I want a little bit of money. She's like, "Okay, I understand it."
Now you don't have to fight that much.
Yeah.
Awesome. Again, as a reminder to people joining in, I'm just catching up with Anjum, but feel free to say hi. We'll just get started in a few minutes. I have to leave the side lid open of my PC. I'm sure you've seen the case, right? Like it's a mess, honestly. This is the other one, the main one that has the two 3090s and A6000 is over outside of the frame.
Yeah. Yeah, mine I've got some extra fans jerry rigged inside mine, so it points towards the GPU and stuff. So that kind of helps. And I also found that obviously there's variation because on the 3090 the memory's on the back, right?
Yeah,
and there's just thermal pads on there. So there's a little bit of variation on how good they are, like cooling down. So I found that just swapping the order of the GPUs, there's one GPU that keeps cooler than the other one. I found that helps a lot.
interesting. Okay. Yeah, I just have the MSI one, so it's different.
That's cool.
Awesome.
Yeah.
All right, I'll just get started. I'll take a
Cool.
pause and get started. So just one moment. So, hi everyone, thanks for joining the first Kaggle talk. I quickly want to point out that we'll be taking questions to the forums. So, this is discourse. By the way, if you're not familiar, you can like posts here. I can't like my own post, but make sure you say hello in this thread. And if you'd like to ask questions to Anjum, you can post them here. I'll ask him what is his favorite chai, and hopefully it should go through. So please ask your questions there, since we're also live streaming on YouTube and we're in the Zoom call. It's difficult to monitor everything. So I'll be taking questions from here. All right, with that, I think we're all set to get started. Welcome to, this is, I think, the first Kaggle talk at Weights and Biases, also the first Chai Time live and the Chai Time walkthrough. I'm like incredibly excited to be hosting Anjum. I've known Anjum for a few years through the Kaggle Noobs community. It's an incredible community. And I just saw his icon. I was just telling him on the leaderboard. And I was so happy to see him on the 4th position on the CommonLit competition. So I don't think I was at Weights and Biases at that time. I just instantly reached out, and he kindly agreed to also later do this talk. So Anjum, thanks for joining us. I'm really looking forward to diving into your solution today.
No, thank you for having me. It's a real honor, and I'm super excited about this. This is going to be really fun.
Likewise, I have gone through a solution, so I know a little bit more, but I'm sure everyone will get to learn it a little. Real quick, I'll point out the resources. These are there on the thread as well. You can find Anjum's write-up on Kaggle. That is just a high-level description. He's also published his GitHub repository, which you can find. If you're new to Kaggle, I'll probably point this out, but Kaggle has this new mechanism where you can train models offline for a few competitions, and then you're forced to do inference on Kaggle. So you're like constrained in a way of how crazy ensembles can you build. Anjum still built, I think, around 30 or 38 models, if I remember
38
correctly.
months,
So
yeah.
there's still some leeway there. I'll be using a dashboard that one of our ambassadors built because I'm lazy and I didn't want to do EDA. So you can check that out as well. And this is essentially CTDS 2.0, like I pointed out on Twitter. So I'll quickly go through what is CTDS 2.0, and here's the agenda for today. After that, I like the reason for me doing these interviews was like, I know Anjum's solution. I know he built these models, but I'm also really curious, like, how did he become this awesome Kaggle competition master? Like, how did he get to the top of, I think, in the top 100 in the leaderboard? Like, I want to know, how did he study these things? So that's why I asked these questions, and we'll be starting there, followed by understanding the competition, and then we'll dive into the data set, and Anjum will present his solution, and you all are free to ask any questions that you want. Keep the questions coming. I'll keep looking at them here and there. So this, like I said, is in a way Chai Time Data Science 2.0, because I ran out of ideas. So that's why I called it this. What I'm trying to do is live interviews here. These are also community Ask Me Anythings. And what we really want to achieve as a community is understanding solutions that are up there on the top of the leaderboard. I truly believe that Kaggle competitions are a great way of learning, and winners, as you'll find from Anjum, have these like interesting techniques that are so buried in the forums, and you can only understand if you've taken part in the competition. So we're trying to uncover those through this series. At least that's what I hope. But I look forward to hearing from you if you find that is the case or not. So I'll start by introducing Anjum. He's Anjum Sayed on Twitter. Give him a follow there. He's competitions master currently in the top 100 of the worldwide rankings. That's out of 166,000 data scientists. He's a senior data scientist at BP, and he's a physicist by background. So I want to start by the traditional chat time data science question and answer. First of all, thanks again, Anjum, for saying yes to this request as well. Really looking forward to knowing more about your journey. I know you started as a physicist, so maybe you can tell us about your journey and how did you find data science?
Yeah, so I've been probably been active on Kaggle for the last 3 years, but I joined Kaggle a long time ago. So I joined Kaggle probably 6 years ago. But yeah, I've been coding for ages. So I think I learned how to code probably when I was like 12 or 13. So my parents got me
Okay.
this Lego set. It was called like Lego Mindstorms, and there was this programmable brick, and you could attach little sensors and motors to it. And I tried to build this photocopier with this like is a light sensor on one side and then like
Interesting.
a little pen on the other side, and it'll scan a piece of paper. And then I found that the little scripting, the coding thing that Lego supplied with this stuff is too slow. So all my images
Okay.
are coming out blurry. And I found these guys at MIT had hacked the firmware for this brick so you could run C on it. So rewrote all my programming C to get this photocopier to work out a Lego. So that's when I started learning how to code when I was a kid. So I started
You
with
learned
C.
C when you were 13?
Yeah.
Wow. Okay.
That was the first language I learned, which sounds
That's
crazy
incredible.
now looking back.
Yeah.
And then I went to, studied physics at university, and I specialized in particle physics. So we started doing sort of detailed simulations of the Higgs decay. So using Monte Carlo simulation, that was all done in C as well, because when you're doing
Okay.
millions of simulations, you got to do them really fast. So we were trying to characterize what the Higgs decay would look like before the Large Hadron Collider started up. So we knew what they were looking for. Kind of knew where the Higgs would sit, but we wanted to see what that looked like. So we did a bit of that at university. So and then I started work at BP as a petrophysicist. So petrophysicist is it's a strange sounding job, but it's when in the oil and gas industry we drill these wells where the oil and gas comes out, and when
Mhm.
you drill the well, you'll send down a little tool on a piece of wire called a logging tool, and it'll
Okay.
measure things like electromagnetic, acoustic, um, nuclear properties of the rock. And it was my job to take that data and then turn it into something useful. So like the porosity of the rock, is there oil or gas or water there? How well does that rock flow? So it's kind of, I was a scientist working with data, but I wasn't called a data scientist at that point. So as are many scientists in data science these days, and at that time, so Python was popular then, but it was almost seen like a little bit of a toy language. So in Microsoft Excel, you can write little macros in Visual Basic. A lot of
Right.
software at that time had Python built into it, so you can do little custom scripts. So if I wanted to build a convert density into porosity, I'd write a little one-liner in Python to do that. So I've been using Python that way in like a little in specialist software like that for 12 years or something. It's quite common, even like in music production software, you have a little Python kernel. Now Python's probably one of the most popular languages in the world, so it's a bit different now. Um, and yeah, so through that, I learned a bit of Python, got more into the sort of statistics and machine learning world, and then I joined Kaggle 6 years ago. And because at that time, all the blogs and things were saying, "Oh, if you want to learn data science, go to Kaggle." And Kaggle was a really different place back then. It was, TensorFlow had just been released. There was no PyTorch. Everything was scikit-learn, XGBoost, like GBM, or the really like heavy grandmasters. They were coding their own random stuff. It's crazy. So
It
I
still
entered
feels
my.
the same, like how you're
It does feel
describing
the
it. I
same
feel,
something.
yeah.
It's a very different landscape, but it's still the same feeling. And yeah, there was a lot more variability. So in back then, the notebooks you could run R and Julia in the notebooks as well. So there's quite a lot of diversity in that. So I entered my first competition, which is every Christmas Kaggle has sort of a Santa themed competition. It's usually an optimization thing. So oh, okay, I can code a little bit. I'll give that a go. and it was so hard. I think I came in the bottom 5%, 10%, and I got terrified. Like my level was so low, I couldn't even understand any of the solutions. I got terrified of Kaggle, and it was probably my biggest regret. I left Kaggle for about, yeah, that's the one. Yeah, Santa stole it 6 years ago. So that was my first competition. I got so scared of Kaggle. I felt like this place was so daunting, and I left. And it's my biggest regret. Anyone who's starting out with Kaggle, don't give up. Just stick with it, because it's the best place to learn. And I really regret leaving Kaggle for a few years. So I went off, did my own thing. I got buried in a hole of deep reinforcement learning and all sorts of other projects. I did a few. I tried to do some courses. I think I started Andrew Ng's course probably about 4 times and never finished it. And then probably about 3 years ago, there was a competition, the TGS Salt Identification Challenge. So that was interesting for me because it had a bit of geophysics. So I was familiar with the data through work, and I just watched all of the fast AI fast AI lectures on convolutional neural nets. I said, okay, let's give this a go. So I think I finished just outside the bronze medal territory, but I was fully committed to this competition. Like there were 3 months, I just really focused on this competition, and
So this
I
was your addiction point, if I may.
this
This is
is
when
the
you got
addiction
to.
point. This is the turning point. And at this point, I was using TensorFlow. So I built a UNet from scratch. I built a ResNet from scratch. I was reading papers. I built with spatial and squeeze, channel squeeze excitation blocks. So those are the bits that are in efficient nets these days. Built all of that from scratch. Just finished outside the top 10%. And that's when the addiction started. And I was when the competition finished, I looked back and I said, wow, I've learned more in those 3 months than I did in the previous 3 years. I thought, oh, wow,
Hmm.
this is amazing. I'm going to stick to this. And then that's when the addiction started. So been competing ever since then.
Yeah, it's been an incredible journey for you. I was looking at your profile, and since then you've made it to the top 100. Again, like it's so incredible. I think like people really underestimate it. Like these are the best of the best competing on the leaderboard, and you made it to the top 100. You have 2 gold medals, 8 silver medals. One thing I'm curious about is you've competed, according to the stats that show up against your profile, 90% solo. So like, is there any reason like you compete solo or?
um, so yeah, I've competed twice. In fact, it's something that I want to try to get into more. Is my New Year's resolution this year to team up more. But the 2 times I've teamed up, it's been really enjoyable. I've learned so much from it, but it's very intense. If you don't want to be that person in the team who's not pulling your weight, right? So if I, like, for example, in the CommonLit competition, I was actually away for the last few weeks of the competition. So I didn't want to team up with someone and then disappear for the last week of the competition. So I kind of like the freedom of being solo, but I do want to team up more going forward, because you learn so much from other people, and that additional intensity when you're in a team is actually really good. But it's unintentional that I am a solo person.
Okay. Yeah, my experience has been the same. Like my like achievements come through just like incredible teammates, and unlike what I expected, I don't need to be at a level. People are like very open about explaining their code as well,
Mhm.
teaching concepts. Like I didn't know, if I remember, label encoding also at that time, and someone was like, just my teammate just sat me down and explained it very nicely. So
Yeah,
it's
yeah, yeah. It's a super valuable experience teaming up. Yeah, and it's something I'm going to try to do more often going forward.
yeah, I look forward to more gold medals, and then we can invite you for more talks, hopefully. But
Hopefully, fingers crossed.
so how's and this will allow me to transition back to the competition. How do you
Mm.
usually approach competitions once you sign up?
So I normally pick competitions wherever there's a sort of gap in my knowledge. So if I want to learn about NLP, I'll join an NLP competition. So I try to pick competitions that have a gap in my knowledge. And I also quite like the sciencey based ones. So I really enjoyed the one with predicting molecular properties. That was pretty cool. So it's quite physicsy. I'm really enjoying the gravitational waves one at the moment. So I like those sort of things. And the other thing is, whenever if you're working on a problem and you always get a little bit of an edge if you research the problem. And I really like researching the sciencey stuff because you learn a little bit about the world around you then. So that's kind of like I always go for this more sciencey based competitions. But yeah, but my sort of a general approach is yeah, have a look around. I'd usually open up someone else's EDA notebook because I'm terrible at EDA. It takes me 20 minutes to make a plot.
I take 5 hours, so you're like
I
magnitudes
know,
faster than me.
I'm pretty sure I've Googled 10 times this week how to change a figure size in Matplotlib.
I'm happy to know I'm not the only one.
So I normally fire up someone else's notebook, and if the data looks really interesting, the competition has like lots of scope for crazy ideas, then I'll jump in. So then my normal approach is, yeah, download the data, and then I'll try to do my own data exploration. Mostly not really getting into the nitty gritty of the data, but the first question I've tried to answer is how can I build a cross validation scheme that's robust for this data set? So, for example, if it was for, say, medical data, you might want to group by patient ID and stuff like that. So I will try to really quickly explore the data to see how I can get a robust cross-validation scheme. Because if you don't have a good cross-validation scheme, you're blind. Ideally, you don't want to be relying on a public leaderboard for anything. So I kind of treat the public leaderboard, if you're doing 5-fold cross-validation, treat that as a 6-fold, not as your private
Hmm.
leaderboard. Um, so I try to do a little bit of exploration, not too deep, try to finalize my validation scheme, and then try to get a baseline submission on the leaderboard within 48 to 72 hours. The reason I
Okay.
tried to do it too quickly is because I might get distracted by something else and go somewhere else. When you fire up a new data set, you get excited and you want to do it quickly. If I don't do it
Yeah.
within that time frame, I'll probably lose interest and do something else. So I tried to get on the leaderboard, get a baseline model on, and I tried to do that without looking at any of the existing public notebooks. So, because yeah, that way you've done everything originally and you're not biased by any other people's thoughts. And even if it's right at the bottom of the leaderboard, you've already got your pipeline in shape and you can start tweaking ideas. And then normally once I've done that, I have probably 4 rules I try to stick to when I'm doing a competition. The first 3 rules are pretty standard. There's a fourth
Mhm.
one I probably picked up probably a year and a half ago, and that really helped me boost my leaderboard position. So the first one, and since I started competing on Kaggle, I've never forked a public notebook, never.
Okay.
So if I like a notebook, I'd always upvote the notebook. It helps the authors. And then if there's something I like in there, I'll always re-implement it from scratch. And that way you really understand what's going on in the code. And if there's any bugs, you'll catch it. Abhishek Thakura, his saying is, if you didn't code, you didn't learn. Because if you
Hmm.
just hit the fork button, you don't know, it's very, you might scan through the code, but you might not comprehend what it is.
It's
Um,
like this weird. You nod to the cell and you press Shift Enter, but when you try to replicate, like then you realize, I'm not that good. I don't feel as smart as I was like doing earlier. At least for
Yeah.
me, that's how it is.
Well, like it just going through the motions and re-implementing something from scratch helps really cement an idea and a concept in your head. And the other thing with public notebooks is that people publish notebooks for different reasons. So last week I was trying to learn something new in the gravitational waves competition. So I published a notebook on wavelet transforms just because I wanted to better understand it and I wanted to get feedback from other people. Um, just because I published it, I wasn't saying you need to use this on your pipeline. It was mostly to get feedback, and it probably definitely bugs in there. It's probably definitely better ways of implementing that thing. But you know, so you just be aware that people publish notebooks for different reasons. So a lot of the time is because they want to learn as well.
Yeah.
So that's when I started Kaggle. That's the number one rule I tried to stick to, which I kind of do. um, the other thing is never to use ideas from the discussion boards without testing them,
Mm.
because there's a lot of really good ideas on the discussion boards. And you know, if someone says, "Hey, I did this and I boosted my leaderboard position by this," um, they they might be right and they might be wrong. You know, the Kaggle boards are really is probably the friendliest place on the internet. I love it. It's a really good community, and I don't think people share malicious knowledge on there intentionally. But if there's an idea shared on there and someone gets a leaderboard boost, it might not translate in a leaderboard boost for you. And there's a whole number of reasons for that. Maybe they're using a different validation scheme. Maybe they only tested it on a single fold, or maybe they have a leakage in their cross validation scheme. So it's always don't take an idea from the discussion board and then just go with it blindly. Always
Yeah.
test it. Um, and then the third thing I try to stick to when I um, when I'm doing my sort of experiments is, it sounds really simple, and it's really hard for me because I'm a very impatient person, but just to change one thing at a time. Um,
Mm.
so you know, in science,
It's
if
the
you're
same for
trying
me.
yeah, in science, if you're trying to figure out if changing something actually made a difference, you can only tell if you only change one thing at a time. And one thing you see quite commonly on the discussion boards is, you know, let's say you're in an image competition and someone says, "Oh, I got this much of a leaderboard boost by going from efficient net B0 to B7."
Mhm.
But obviously, you're going to have to reduce your batch size to fit a B7 model on your GPU. So you've changed two things there. So how do you know if your batch size has made the difference or the model has made a difference? So you just got to be very careful around changing one thing at a time. It's very difficult, especially with deep learning, because things take a long time to do. And if you're impatient
Yeah.
like me, it's very hard to, maybe I'll change this and this at the same time. It's just got to be patient and change one thing at a time. And then the last thing that I've really tried to focus on in the last few years, and I think it's been working okay for me. And I think maybe CPMC said it one day, but he said that the best Kagglers don't always have the best ideas. The people at the top of the leaderboard don't always have the best ideas. They just have the ability to test the most amount of ideas in the shortest amount of time. And I really
Mm.
tried to focus on that. So you know, if you read a lot of the previous solutions, unless there's a problem with the data set, like a leakage, or there's some sort of difference between the train and the test data set, a lot of the top solutions aren't, there's not one magic, right?
Yeah.
There's not one thing that makes it a top solution.
I mean, unless there's a leak, and those aren't
Yeah,
common anymore, luckily.
yeah, yeah. So I would say 90% of the competitions, the best solutions are just a really good culmination of lots of small ideas, right? That work well together. So if you're able to test lots of ideas quickly, that's going to really help you. So one thing I try to do is just work with a small model. You know, if you have a really big data set, maybe work with half of the data set or
Hmm.
10% of the data set. And you know, if you see in the discussion board someone's got a great score with an efficient net B7, stay with B0 for as long as possible, right? So, and it allows you to get your idea iteration down rather than days, get it down to
Yeah.
hours and minutes, and you can just test so many more ideas. And that kind of philosophy works well in real life, right? You know, like a Formula One team, they don't build full scale cars to put in a wind tunnel. They have model cars. Or there's a guy called Gordon Murray. He used to build Formula One cars, and he's building a new car called the T50, and it's got this brand new V12 engine in it. He went to the
Mhm.
company called Cosworth to build it, and they didn't bother developing a V12 engine because that would be too big and expensive to make every time. So they built a 3-cylinder engine, did all their development on that, and then scaled it up because it's 1/4 the size and 1/4 the cost. So I tried to approach my experimentation that way. So stay small for as long as possible. Try to iterate your ideas in minutes or hours rather than days. And then once you get towards the end of the competition, then start training your bigger models. And it seems to be working all right for me so far. That's probably when I started to see the biggest change
Mm.
in my performance.
I want to highlight like how incredibly difficult that is, because like I've recently started competing again and I found my old post which was from my first competition. That's how I recall this. But like my intuition at that time, and I'm sure this might be for a few people, is to just like throw the biggest model, because if I throw a ResNet at a image classification problem, it should work, right? Maybe not ResNet, maybe EfficientNet B5. Like it should work. That's the best model. Like I should just throw the complete data. No, 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 no. You'll find
Yeah,
out the hard way three
yeah,
days
yeah.
later.
Exactly. And it's always tempting because you always see that one guy on the discussion board saying, I've got this score with a B7 or whatever. And you're like, oh, and it feels good to get up to the leaderboard, right? It feels really good when you train a big model and you get up. But it feels even better if you can match that score with a tiny model with a bunch of really good ideas. And then when you train the big model, it's even better. Um, and it's also good, usually in the competition, there's a thread that says best single model. And if you
Yeah.
can put a post out there saying, oh, I've got this score with a ResNet 34 or something like that, it really helps if you want to team up and stuff like that, because people see that and it's good. And it's just easier to iterate ideas. You can test more stuff quicker. And yeah, my mantra is test the most amount of ideas in the shortest amount of time. And that I try to write my code to help that, so I can just line up experiments one after another and do it quickly. So we can get into that later on. Yeah.
Yeah, we'll definitely be diving into the code base. Anjum has agreed to do a walkthrough for us, so that like no one is upset with that. But what I'll do is I'll start by describing the problem, and Anjum, you can help me out if I miss out on any point. So what I like to do is I usually just head over to the page, try to read around a bit, try to understand. Sometimes like my biggest mistake has been like not to read this thoroughly, and then 15 days into the competition I'd come back and realize, oh, I should have just read this.
Yeah, there's often
So
quite a lot of little subtle things in here that you can just, if you scan through, you might miss, and then you read it again. It's like, oh, that's why the data looks
yeah.
like this, or something like that.
Yeah, so I've already read through this, but the problem statement here is usually people use tools like, I don't know how to pronounce this, so I won't. And I haven't studied literature in a long time, so I had to look up what syllables are. But for different grades, they have this score of understanding how difficult or easy a passage is, and the argument by the organizers. So organizers here is CommonLit, which is an organization that makes students better readers. So they're trying to help them through this competition and other softwares. So their argument is this isn't the best way, and they wanted the competitors to use machine learning to help them.
Mhm.
After this, I usually hover over to evaluation, because sometimes the metrics are weird and then I have to like find a kernel where it's implemented so that I can copy it. But luckily here was the RMSE, which is pretty straightforward. The reason it's RMSE is for this problem, remember I just said about this code, you need to the targets are these scores and you need to predict this number. So that's why it's a regression problem. And for regression problems, you have root mean squared error. I'm not going to describe that, but please feel free to ask if you're not clear on that.
And this is quite unusual for an NLP problem, because normally with NLP, you might be classifying something or trying to extract a sequence. In this case, it's a regression problem, which is I've not seen in NLP before, but it's quite unusual. So yeah, it really, and the other thing with RMSE, you can, if for a loss function, you can directly optimize that as well. So
Yeah.
in this is in a lot of competitions, if the metric is not directly optimizable, like AUC or something like that, you have to use a proxy loss function. But for
Yeah.
RMSE, you can directly optimize that, which is handy. It makes things easier for us.
For AUC, I remember you can just like make 0.5 predictions and then you get a nice score and you get deceived as if you're doing a nice prediction, but you're really not. So you have to
Yeah.
come up with tricks there. But yeah, like I was looking at the data and it's this incredibly small data set of I think about 2,500 rows. Let me switch over to column. So the columns here are, and I've already gone ahead and written about these. Please excuse this writing, but these are the columns. You have the ID, which is the ID of the text. The URL is there for source. I'm assuming people might have crawled websites. Kagglers do like fancy stuff, so maybe that's why they left in there. Licenses talk about, for example, is it by CC by 4, which means that can you just use this and like build upon it as long as you give credit. Licenses are like quite nitty gritty. I don't want to get in them, but like these usually give you the freedom to work with data. Then there's the excerpt, which is the main NLP meat, and there's the like words of the paragraphs that you need to understand. Your model needs to understand and predict the target. And then there are the errors. Now these, again, the one thing I learned after a while was there were different reviewers which had given these errors. So that's why like there's a spread of errors out in here. Awesome. Did I miss anything here, Anju?
No, that's it. Yeah. Yeah.
Awesome.
So I guess if you expand this, you can kind of see the distribution of the target variable. There you go. So it looks like it's almost like a Gaussian distribution, but not quite. And you get scores from say -3 to +2, and relating to how difficult a passage is to reading. And I think yeah, so the scores were, I think they were derived using something called a Bradley-Terry model, and
Okay.
there were, I think they asked lots of teachers to with pairs or combinations of these excerpts and tried to ask them which one is harder, and then they
Hmm.
used those put all of those ratings in a matrix, and then there's some sort of model that converts those ratios to a score like this. And because not all of the teachers saw all of the excerpts, they were able to calculate a standard error on that prediction, which I thought was an interesting feature. And was one of the reasons I jumped into the competition, because I work with uncertain data all the time with work, and how you treat errors is you have to be quite careful. But in the end, the standard error didn't come in that useful, but we can talk about that later. But it was an interesting feature, interesting thing to add to the data set.
Yeah, sounds interesting for sure. And yeah, it does look like a Gaussian distribution. Again, we'll not go into that depth. If you're not clear why those are important, feel free to ask. We'd be happy to go into that. But this is a slightly advanced discussion, so I'm just skipping over those details. Please don't feel like you're not welcome to ask questions as a reminder. The thing I like to do here afterwards is I just usually hop over to code. I sort by best score. I do some hyperparameter tuning and submit, but that's not that's not why I wanted to point these out. We have a few Kaggle grandmaster who's also who are also our ambassadors who've created these nice dashboards for us. So I'm just going to go through those to again highlight a few details about the data since they've done the ED and I didn't want to butcher their work. So this is by Andrada Olteanu.
Yeah, I love Andrada's notebooks. They're always so good.
Her her notebooks are just like this incredible artisty ones where
Yeah,
you get to like it's just a
they're always
different
so
dimension.
beautiful.
Yeah, exactly. I think this is more of a baseline. So
Yeah.
I'm confusing myself. I wanted to show Ruchi's dashboard. Ruchi is also she's a 2x Kaggle grandmaster, and she did this EDA inside of her kernel, which is you can find this up. I'll request Andrea to share this
Mhm.
as well. But the nice thing we can do is since she's created a dashboard, I don't have to go through a notebook. I just get all of the details right here, and we can glance over those.
Yeah, this is really cool. So I didn't know that you could do this with weights and biases, because this is kind of like a Power BI or Tableau sort of dashboard view. I've only used it for sort of model logging, but this is super cool. Like this is when I saw Ruchi's notebook, I was like, wow, I didn't know you could do this.
Honestly, I learned after joining as well, but don't tell my colleagues. So, all right, let's go through these quickly. Would you want to like walk us through these since you're like familiar with the data?
Yeah, so there's Ruchi's done a great work of like exploring it, exploring the data, trying to see how there's like the average word length distribution and things like that. These are pretty cool summations of how what the data set looks like. So one of the more interesting ones I saw, if you scroll down to the flesh reading ease one. So yeah, there was quite a, if you scroll up a little bit,
Sorry,
like yeah, it's that gray chart.
I'm using
So
an external mouse, so that's it.
oh, okay.
Yeah.
Yeah, so there was a lot of she related the flesh reading ease, which is I think she calculated using a package called TextStat, which I used in the end as well.
Mhm.
And it is also able to come up with a distribution which kind of looks like the target distribution. And she did a really cool correlation matrix. I think it was back in the original notebook of how different ways of calculating a readability score using the more classical techniques correlates with the target variable. So if you go back to a notebook, I think.
1 second. Like Zoom comes in the way right at the top of
Yeah.
my browser window. So I'm just trying to fight that. Let me move that to the side. Now we could.
Yeah, so this was really cool. If you,
I'll
yeah,
look up reading. I'm just trying to find the word so that I can move over
it's,
there.
yeah. If you click on the right, it says readability tests, the test tube.
Yeah, gotcha.
That one.
I'll just have to scroll. Kaggle is annoying sometimes. To their credit, like
Yeah.
if you remember Anjum, it was like a little worse a few years ago. Now it's
Yeah,
like
yeah,
much
it is
better.
so much better now. Yeah. Yeah, look at these charts, they're amazing.
Yeah,
Would
for
have
sure.
taken me days to make this. So there's different text properties and things like that. We keep going down,
There we go.
keep going, keep going. This is the one. This was a really interesting chart for me when I found Ruchi's notebook. So the bottom line is the target variable and how it correlates with different sort of classical readability tests. So there's the flesh readability, the one we were talking about before. There's a correlation of 0.52, which is actually not bad, right?
Mhm.
So if you were planning to add additional features to your models, that could be a way to go. And I did try that. And yeah, there's all these other readability features. They might be negatively correlated, but yeah, really interesting stuff. And the other thing I saw, which is interesting, if you scroll up to the, I think it's one of the second plots, so right at the top.
Sure.
Sorry, I'm making you jump around.
No worries. The
The
thing
one with
about
the,
Zoom is like there's a lag between the scrolling, so maybe
oh
I'm at
yeah.
the right one, and then yeah, I'm past it in a second. Is this the one
So
missing
no, the
values?
next one I think maybe, or the one with the standard error with the hexagons.
I think it's there in the dashboard as well.
Yeah.
Um, this one?
No. Well, it's kind of related to that, but it was a scatter plot in the notebook with the target variable versus the standard. This one, yeah, this
Gotcha.
one's really cool. So we've got the target variable going along the bottom and then standard error along the top. So normally so what this chart is showing, there's a relationship between the target variable and the error. So statisticians invented a really hard word to say for that. It's called heteroscedasticity. I don't know if I said that right. So it's when the error of something is related to its value. So normally when you're doing, say, a linear regression, you assume that the error is a constant all along. But I spent a long time thinking about this data set. And I thought, well, actually, the really hard to read samples and the really easy to read samples, there's a fewer number of samples for that. So if they're calculating a standard error on that, the error will be wider just because they got fewer really hard to read or really easy to read samples. So
That
that's
makes
why the
sense.
standard error will be larger. So I think that this smiley face trend is actually related to the number of samples you have at the extreme ends of the target rather than an actual feature of the data, which is why I
Hmm.
think in the end, the standard error wasn't too important for this competition. But it's an interesting thing to see when you're exploring the data.
Yeah, I guess you could only understand that through this plot. Otherwise, it
Yeah.
wouldn't have been that clear. I think. Um, let's quickly glance over the common words. So she's also plotted with weights and biases. You can just log the graphs, and
Mhm.
luckily, then I don't have to scroll and I can just look at these plots right here. But it's also interesting to see that apparently school kids are being told a lot about carbon dioxide, probably for good measure, and different words. I don't think these like mean a lot. Probably these
Yeah.
appear a lot in the excerpts.
Yeah. I had a quick scan through. So there's that licenses column, and a lot of the articles were from Wikipedia and things. Was it the licenses or no, it was the source column or something? Um, and yeah, there's a lot of articles from Wikipedia and more sciencey based stuff. So things like
Hmm.
voltage or yeah, something like that. So might be quite a lot of sciencey based words in here. So I thought that was interesting as well about
Yeah, I don't know
understanding.
why they would make high schoolers read Wikipedia pages, but I saw a lot of Wikipedia links there as well.
Yeah. But yeah, this is really cool. This is really interesting use for weights and biases. Um, so yeah, Ruchi did quite a lot of more classical NMP stuff. So looking at unigrams and bigrams and stuff like that. And this is a really cool approach. So when you make your first baseline model, it's always good to take the simplest approach. You know, if you start with a new data set and then you're doing a regression task, start with a linear regression rather than going straight into a deep neural network.
Yeah, I was
Um,
gonna say GPT 2 or 3.
yeah. So doing this sort of classical sort of NLP techniques, it's really cool to see.
Yeah, one more thing, like why this is useful is we can also see the average word length distribution, and this is also helpful when you're like creating word sequence for different transformer models also. So that's why like ED is quite important. All right. I have a few more dashboards open, but I think we've covered those. So the next thing
Mhm.
I want to hop over is Anjum solution. Is there anything else you want to discuss from the dataset?
No, I don't think so. I think we covered most of those things. Yeah.
Awesome. Let me quickly close these tabs. One moment. So I'll quickly glance over these and then I'll request Anjum to go into the details. But one thing I learned was he didn't do a separate CV setup. Apparently, the local CV and the leaderboard were quite correlated for this competition. This is quite important to understand because when you're competing on Kaggle, you have your local accuracy, which your models would spit out. And you need to keep looking at those because those are the ground truth for you, at least at that moment. And on Kaggle, you just get 5 submissions. So throughout these few months of competing, even Anjum has made 76 submissions. And if you can like have a good ground score, that becomes your truth. Now you don't need to submit to Kaggle every time. You can just trust that. So
Mhm.
that's why on Kaggle you also see this phrase called "trust your CV," which is basically just trust your local CV once you
I
set it
think
up.
there's even a team called Trust Your CV, right?
Yeah, I think Chris Diot names his
Yeah.
team "Trust Your CV." So he used Abhishek's method, which we can discuss in a bit. And after that, he added an attention block to the last sequence state of the transformer. I've done a very poor visualization of it, but I'm guessing this is what it was like. You would just
Yeah,
add an
yeah, yeah.
attention block to the output, and then
Mhm.
you also had these text features, which we can discuss in a second. You would just
Yep,
concatenate these,
yep.
after which you would just run this through a regression head. So guys, if you remember, this is a regression problem because we're trying to predict this target from here. So we get a number and then we can calculate the root mean squared error. Is this correct? Or is this a correct
Yeah,
representation?
that's spot on, spot on.
Awesome. And these features I was just talking about, and I'm also personally curious, like you mentioned these weren't quite helpful as you expected. You used these features. Maybe you could elaborate what these are.
Yeah,
And turned out these weren't impactful. So I'm also curious, how did you discover that?
yeah. Okay. Where should we start? Should we get into some code, or where do you want to go
Sure,
next?
sure. Do you want to
So,
share your screen?
so yeah, let's do that. Um, Let me see. Uh, If you, I've forgotten how to share
There are
screen.
all of these like details that we can read through the solution, but if you've not completed, you probably wouldn't understand them so well. So that's why I was really excited about this walkthrough as well for a session.
So can you see this screen at the moment?
Yes, I see the
Okay,
Kaggle write up.
cool. So one thing, if I start with a small data set, like this one, so I normally do my baseline model, and yeah, so I used Abhishek's binning and stratification code. So let's go to data, right? So we'll start with the data. So one thing I do, if I copy someone else's code, I'll always attribute it at the top here, just so that I know where I got it from. And then if anyone else copies it, then at least they've got some attribution. The only thing I
That's
changed
incredible.
with Abhishek's thing is I added this bit, so the random state. So so the way what Abhishek has done here is, because this is a continuous target, but we want to create our five folds to look as equal as possible. So they look, when you take a random sample and have five random groups, you want
Mhm.
those five groups to look as similar as possible. But so he binned it using this function called pandas cut, using a number of bins, and then split it up into five folds. So one thing I generally do if you start with a very small data set is change this random state and when you do the stratified k-fold, and then run another experiment. And if your CV score changes by quite a lot, that means your score can vary. Your score varies just by pure randomness, right? And
Yeah.
I found that I did some experiments. I changed this random state, and I saw my cross-validation score jump around quite a lot. It's very sensitive to the random seed. I'm not, and don't get confused. The random seed is not a hyperparameter. It's not supposed to be a number you tune. It's
Hmm.
just it just shows you how noisy the data is. So when I did that, that's when I knew that if for my cross-validation scheme, I'd have to run my five folds using lots of different random seeds and track that. So that actually ended up being quite a lot of experiments. So I was going through my weights and biases dashboard, which is this. So my dashboard is not as pretty as Ruchi, so it's very, very minimalistic. But is I usually set things up like this. So you can see for each experiment, I had 25 runs. So that is five seeds and then five folds. So I usually set up my models like this. So each run has a timestamp, and then you've got five folds in there. And then I've grouped it by something called a slug. So this is a really cool Python package called coolname, and it just gives
Okay.
you a random name. Some of these names are excellent. So like spectacular hyena refinement, clever demonic trout.
I love it.
It's super
That's
cool.
awesome.
So there's a package called coolname. So remember, so the way I would, if I go back here, so the way I would kick off my script is I would have some entry points, train and infer, and I keep my code in this source folder. And then I kick off my train scripts using this shell script. So I have five different random seeds, and you can see I was playing around with other seeds.
Hmm.
This is the cool name thing I was talking about. So it'll
Gotcha.
generate a nice, a funny name for the group of names, and then it'll run five folds over these five seeds, and then you'd end up with 25 runs like this. So this was pretty cool. And if I go back here, if I go have a look at the project.
So your baseline, I'm just looking at the loss curve, was around, I think,
So
0.3.
yeah, somewhere around that. So you can see that the loss is very noisy. The train loss is pretty smooth, but the validation loss, because it's quite a small data set, it jumps around quite a bit.
Makes sense.
I'll go into that in a second, because I'll show you how I found. Essentially, you want to try to find the best model in all of this, right?
Yeah.
So it was quite cool using. Oh, here we go. Yeah, so I've got for this competition, I did 2,300 runs.
That's incredible.
Yeah, so
I
which
mean,
is
that
crazy.
that just speaks to like how many experiments does it take to get to the top of the
Exactly. So
leaderboard?
it comes back to what I was saying earlier, the mantra of test as many ideas in the shortest amount of time. So if I go back to I usually have a shell script like this, and I can write another shell script just to line up experiments. So I just keep running train with different set of hyperparameters. So I'll have a file here like hyperparameters.yaml, and I'll have hyperparameters for all my different models, and I could just type them in, line
Gotcha.
up all my experiments, and then go meet my friends, and then come back in. And then my machine's been working at 100%, but running lots of ideas.
And the room is at boiling temperature when you
Exactly.
walk in.
So I would say the initial first few hundred runs I did with Roberta Base. So this was on my machine. It probably took about 6 minutes per fold. So I try to again, coming back to the mantra of test as many ideas as short as possible. I wanted to get my experiment time very short so I can test lots of ideas. And because I had to test across lots of different random seeds, I had to do 25 runs of that, so 25 times 6 minutes. And also to track that as well, so I used a Google Sheet. So this is what my Google Sheet looks like. So there was actually, if you go into my repository, there's a little Python file here called ag scores, and this writes my cross-validation scores to this Google Sheet. So you can see that this is the group. These are the 5 runs that I did along the 5 seeds, and then these are the 5 folds. And then I would take the average of these scores in a sort of a pivot table like this, and then that would be my final cross-validation score.
Okay.
So that's how I knew if I changed something in the model, if it was making something better or worse. If I changed any parameters in my attention block, if I was adding any more features, anything like that. So I was using these 25 runs and essentially averaging those to generate my final cross-validation score.
Gotcha. I'm also curious, why did you pick Roberta as like the baseline model? Like, what was the intuition there?
So yeah, good question. So Roberta is generally a really good all-rounder. It runs fast. So Roberta base runs fast. So that ticks my box for having something I can iterate ideas fast. And it just works really well. And so the other thing I did is, well, if we go to Hugging Face, models, Roberta. So Roberta works well. If you go into the paper, there's lots of reasons why it's such a great model. But one of the reasons is that it's trained on a huge amount of data. And if you have a look at what it was trained on, I love these little model cards on Hugging Face. They're really useful. It was trained on Wikipedia, which is cool because we have lots of Wikipedia in our data set, and something called book corpus, which is interesting because I think in the CommonLit data set, you can see there's some storybook style excerpts from stories. I think there was something called African Storybook or something like that. And then there's another story data set. So I started with Roberta base because it's super fast to run, worked pretty well. A lot of the public notebooks were getting pretty good scores with that. And then from that, I sort of branched out. So if you go back here, Hugging Face has a really handy way of filtering models here. So if I wanted models that were trained on Wikipedia, I could click on this button and there's all these other models that are trained on Wikipedia. And then there's interesting models with like, funnel transformer, Bert, Albert, and stuff like that.
Did you
And you can
try
try
any
those.
of these as well in the
Yeah, tried them all.
experiments?
Tried them all. Yeah.
Okay.
So one of the really cool things is about Hugging Face, and this I like this a lot, is they have these classes called auto models, and well,
Mhm.
they call it the auto classes. Let's go back to Hugging Face. Um, so in transformers, where do they have them? Auto classes. So they have all of these things. So auto config, auto tokenizer, auto model, and essentially you could use this class, and you just have to pass it the name of the model you want to do, and you don't have to change any of your code. You can just switch your model. So that's what I did. So if I go
You
back
can just
to
add it as a parameter and then tweak that
exactly.
in your bash script.
Yeah, so that's what I did. So in this hyperparameter file, I just had the model name, which is essentially this name here, um, for all of these different models. And then in my code, if I go to models, you can see that it's just using these auto classes. So I load the configuration using that model name. Um, the tokenizer, which is in the datasets file, it loads that from an auto tokenizer, and then auto model as well. And that's just using the model name. So again, coming back to the same idea of testing as many ideas in the shortest amount of time. If you can parameterize your code so that you can just change one string and completely
Yeah.
change your model architecture, you can iterate ideas so much faster. Um, so
How
that's
much
essentially. Go
how
ahead.
much
Yeah.
extra effort does it like do you put in to like set up the repository? Like how much time did it take? I'm guessing it's less because like you've been in data science for a long time. So like is this how you always start your experiments? Like
Yeah,
yeah.
I guess like it's a process I've evolved over time. So now, I think Abhishek did a really good video a while ago about how he sets out his
Yeah.
folders, and I think I started with that, and I sort of swapped and changed stuff for how I work as well. And then, yeah, I sort of converged on this sort of layout. And then the other cool thing is I learned the other day is if you go to GitHub, you can set up something called a template repository. So is this going to work? So I made a repository called Kaggle template. You guys can use it if you want or whatever. And you
Okay.
can hit this button. You go into the settings, say set this as a template repository, and you say use this template, and then you just set a new repository name, and then it'll create a new repository using that
Hmm.
template, which saves you a lot of time as well.
Yeah,
Um,
that's incredible.
Yeah, so I've started using that quite a lot. There's another tool called Cookie Cutter as well, which makes template repositories for you. It's quite heavy. It's quite customizable, but for what I need, these sort of GitHub templates work well. So I kind of yeah. So I usually have two entry points, train and infer.
Mhm.
Um, I'd have a shell script which calls train, and then I can write another shell script which will just do lots of experiments. All I do is change the name of the configuration, and then most of my code lives in this source file.
Awesome.
So that's
Shall
normally
we
how
dive
I
into the
set.
models?
Yeah, let's go into that. So this is the model.
I
So
just wanted to point out that like I was really curious. Like it's quite confusing to understand how do you add a regression head, and it's just like adding a simple linear layer, if I remember correctly.
mhm,
That's how you
mhm.
done it.
Yeah,
Yeah. Sorry to
it's quite
interrupt you.
it's okay. It's quite confusing terminology because and lots of people ask, well, what's a head? So in my mind, what a head is basically the bit at the very final part of the model is the bit that makes the prediction, and you use a pre-trained encoder or pre-trained ComNet, whatever, that does all the heavy lifting, and it generates a feature at the end, just a tensor of some shape, and then you pass that to your head, which turns that tensor of some shape into a prediction. And in this
Mhm.
case, it's a prediction of shape 1 because you're just predicting one value. In other cases, that prediction could be a segmentation mask or something like that. So that's what people mean when they talk about a head. So it's basically going from a feature that's extracted from a big transformer or ConvNet or something, and you turn that feature into the actual thing you want to predict. So this is my model. So I use PyTorch Lightning, which I really enjoy using. But if you're, I would say if you're learning how to use PyTorch, or if you're new to deep learning, maybe don't use PyTorch Lightning, because it's good to write your own training loops and validation loops and stuff like that, because you really learn how things work. If there's a bug, then you know where to look for it. You learn how to calculate your own metrics and stuff. But once you've done that 20 or 30 times, there's only so many times you can write your own training loop. So I
I
use
want to do a
PyTorch.
shameless plug as well. Sorry to interrupt you again, but
Go
like
ahead.
we'll be reading this book, which is Deep Learning with PyTorch. This is by the Codebase, and one of the author will be here next week for a webinar. So if you're new to PyTorch, I would recommend signing up for that.
Yeah, absolutely. Yeah. But yeah, PyTorch Lightning is really cool. But yeah, if you're new to PyTorch, I'd totally recommend just writing your own loops and stuff, training loops, validation loops, metric calculation, things like that. So the PyTorch Lightning it works. You have a Lightning module, which is actually just a normal Torch module, which you'll probably cover later.
Yeah.
And then you define all your stuff here. So here I defined my model, so my transformer, and I also defined my head, and then the regression head here. So at this stage, it kind of looks like a normal PyTorch module. So you have an init function, oops, and you have a forward function, which is normal PyTorch.
The
And
normal
then
forward pass.
yeah, and then the only different bits with PyTorch Lightning is you put what happens every training step. So with PyTorch Lightning, you have a separate class called a trainer, which deals with all the loops. And then that trainer calls these additional functions to do stuff. And because a torch module is just a normal Python class, you can put anything in there, and that's what they've done. And you can make your own deep learning framework if you wanted to. You can just put anything you want in these classes. So my model is a transformer, which I defined using this input argument called model name, and then it outputs a state, and then that state goes into the head, and then that head calculates the target variable.
Right at line 92, we can see the attention head as well. You were just talking about
Exactly.
the attention head that you've added. And at line 90, I believe you add the regressor head, which we were just talking about.
Yeah. So it's probably easier to show you what's going on in, say, maybe a notebook. So let's say if you've got a model, so I've got a Roberta base here. I've got a tokenizer here, so auto tokenizer, which I've called from this model name parameter. I use the config as well. So these config files are useful for Hugging Face because they have some internal parameters of the model. So sometimes it's useful to know what's the output size of the transformer. So then you can, you know what to do there. So for example, I want to know the hidden size. So it's 768. So if I know that is 768, then I know that my head has to accept a tensor size 768. So these auto model classes are super cool. You define the model like this, and then you define an input. So I've got like a little string here. Sorry, my dog is very naughty. And then
I don't hear him yet.
and then you get the outputs. So you can have this flag that outputs hidden states as well. But so you get an output which is this ODict. So you get something called a last hidden state, a pooler output, and if there's these optional hidden states. So that's the output you get from the transformer. So the idea of the
Sorry,
head is.
could you
Go
please
ahead.
repeat what's pooler output? I wasn't clear on that.
So So you've got, I'll explain in a sec. Yeah. So you've got different hidden states. So let me show you. So you've got hidden states. So this is from each layer of the encoder. So this is actually a tuple of uh, hidden states. So we've got 13 hidden states here from different layers of the transformer.
Mhm.
The last hidden state is a tensor, which is this shape. So this is
Mhm.
batch size. This is the length of the sequence, which could be 256 or whatever. This number changes depending on the length of the sequence, but you can fix that and then pad it to, if you've got short sequences, you can pad it to a certain size. And
Right.
then you got the pooler output. So to send this to a linear layer, you need a one-dimensional tensor, which is what this is, right? So you go from a tensor like this, and you need to reduce one of the dimensions. So you need to get rid of this dimension here. So what the pooler output does is it takes the mean along this dimension. So you've got
Okay.
a tensor of 768 by 9, and you just take the mean of those 9 rows, and
Gotcha.
then you end up with a um, tensor that looks like this, and you can pass that to a linear layer then. So you go from 768 down to 1, which is your target output target.
That makes sense.
Um, so the pooler output is cool, and if you go into the Hugging Face code, they use mean pooling, um, and mean pooling is cool. But if you think about it, a mean pooling is kind of just, it's a weighted average, but the weights are the number of features, right? So what if
Hmm.
you could just do a weighted combination um, that wasn't mean? You could choose what those weights are. So this is where the attention block comes in. So that's essentially what we're doing here. We're calculating what those weights are and then summing them up, which is the same as a mean pooling, but those weights are different. So instead of using this pooled output, I'm taking this last hidden state here
Hmm.
and then reducing this dimension by using this sort of weighted sum. And then if I put that through the attention block using the last hidden state, I end up with a one-dimensional tensor. And then I can pass that to a linear layer and output my target that I'm trying to predict.
I
Does
want
that
to
make
plug my
sense?
colleague Aman Arora's session. He just explained attention very nicely today as well. But if you've gone through those, you can understand it. From what I understand, please correct me if I'm wrong. But adding this block at a high level
Mhm.
would like just tell the model on which words to pay attention to, basically.
Exactly. Yeah. Yeah, that's a really easy way to explain it. Yeah. So those weights that if you're just taking mean pooling, those weights are equal for everything. You want, with the attention block, those weights will be bigger or smaller depending on what's interesting to the model.
Yeah.
And it's a more learnable way of getting the model to learn. Okay, given a bit of text, tell me what's the most interesting bit, so for the readability score, rather than you implying almost an inductive bias by just taking the mean of everything.
Hmm. That
So
makes sense.
it's another way of getting the model to learn about what's interesting to help it predict more accurately.
Yeah, thanks for clarifying that.
That's cool. So after I've put that through the attention block, I get a tensor of shape 768, which I can then throw into just a linear head. So if you tell it that n hidden is 768, it'll be a linear head with an output of 1. I've also got 2 here because I was playing around with a different loss function called KL loss, where I was actually trying to predict the target and the standard error. So that other standard error feature we were talking about at the start. Or you can just predict a size of 1. So if you go down to
Hmm.
here, so here we've got the model. You do the forward pass. Oh, I forgot about the additional features. Sorry. So this is the output from the attention head. So this is the shape in the example with Roberta base. So this will be 768 long one-dimensional tensor.
Right.
And then I've got some other features which I just concatenate onto that. So what are those other features? So if we go back to my data sets, here I've got this is the normal PyTorch data set. I generate some additional features. So this is using TextStat, which we had in Ruchi's notebook. And I've calculated the flesh reading ease and smog index, and also normalize those as well, according to some numbers just from that I calculated from the entire data set.
Okay.
So those features, I keep going back and
So
forth.
we're just concatenating those numbers.
So I've got those
with the
two
tensor.
numbers exactly. So I got those two numbers, concatenate that to the output for the attention head, and then
That
throw
makes
that
sense.
into the linear layer, which is the regressor.
Awesome. That makes
So
sense.
that's
And
how
then
we
we
get
can
from
calculate that.
yeah. So that's how we get go from the transformer output. You put that output through the attention head, so you get a one-dimensional tensor. You concatenate two more features onto that, and then put that through the linear layer to get your predicted target.
That makes sense.
And then you push that to the loss function, and then that's what you use to train the model.
I'm curious, were you like also monitoring how much is the GPU being used? Because like I have 3090s as well, but Kaggle has P100s. So for inference, were you like accounting for batch sizes, or like did you think about that?
Yeah, so in my final, let's see. So my final ensemble had these 38 models, and some of these were pretty big. So during inference on the Kaggle GPUs, I had to use smaller batch sizes for those, and it's quite hard because Kaggle doesn't give you much feedback when there's an error. So I'd know. So I'd
I'm
know if
laughing because it's a struggle. Like
I know it's a real
it's
struggle.
funny. Yeah.
You know your submission notebook throwing an error and you have no idea why. So you have to backtrack and see what you see what changed. So I had all of these models. Some of these were pretty big models. So I think I would know if I added this model and I was throwing an error. Well, maybe I'm running out of memory, so I'll have to use a smaller batch size for that. So this competition was a bit strange because the test set was very small. So for say one of these models, you could produce all your predictions in about 10 minutes. But this competition, they gave you 3 hours of GPU time. And I was like, okay, we've got 3 hours. I may as well throw as many models at it as I can in those 3 hours. So that's how I got into this 38 model ensemble, which sounds a bit crazy when you say it. If you were working in my day job, if I showed my boss a 38 model ensemble to predict something, he'd throw me out. But this is the world of competitions, right? And actually the GPU utilization during the submission was actually quite low. Most of that time is actually loading models because these models are huge. These are like gigabytes, right? I think all of these models altogether was something like 170, 180 gigabytes of model weights. So most of that
you
time
mentioned the trick as well in the discussion. Maybe you could highlight that. How did you fit these in? Because Kaggle has a 20 GB limit.
Yeah.
For people that don't know.
Actually, so I think I've still got it here. So I'll show you what I did. So Kaggle has a private quota of 100 gigabytes. So I'm at 97.
Right at the edge of it.
So
That's incredible.
So that was, but 100 gigabytes of models only used probably an hour and a half of the submission time. So I needed to get another 100 gigabytes in there somehow. So there's a
Sounds
trick.
reasonable.
There's a trick that someone, I think, I've forgotten their name. I'll have to go find it, but they shared on the discussion board. There's a trick that if you make a notebook, and then you save something in the Kaggle.output folder of your notebook, those things just stay there and it doesn't count towards your storage quota. So what I was doing is I was uploading my models to a Google Cloud bucket, and then I had this little notebook where I would pull stuff from my Google Cloud bucket
Mm.
and then save them in the Kaggle.working folder, and then I would save that notebook. And I've got, if I go back here, I've got so many of these notebooks just full of, you see all of these timestamps.
Yes.
Same that was what I was showing before. So all these models have different model weights, and you can attach that to your notebook as a data set, and it doesn't count to your quota. So that's how I managed to get up to the
Interesting. Okay.
3-hour runtime limit, just by doing this. Maybe Kaggle will catch on to this trick one
I
day and
was
they'll
just
shut
going
it
to
down.
say, if we get a limit, we know who caused it now.
Yeah. I probably should delete some of these now.
But yeah, that's I love it. That's incredible. I'm sure many people would just be like scratching their head if they found this out now. So like
Yeah,
that
because
was again
it,
nice to
it
hear.
was a real concern for me because at that time, if you were in a team, you had an advantage because you could use 100 plus 100 and you'd have more
Yeah,
storage. So, but luckily, I found this trick that someone kindly shared on the discussion board, and it worked out well for me. But yeah, it was interesting. So
awesome.
let me see.
I think we've
So
understood so far how did you do the feature engineering. Those two
mhm,
features that we added, the models. What's left, I believe, is the ensembling part.
ensemble, but yeah. So
Yeah.
because usually when you ensemble, so this is what I did. So for every model that I had, I would generate a file called oops. So oops stands for out of fold predictions.
Mhm.
So it's really important that when you're running your model in inference mode, so if you train on 4 folds and then you predict on the 5th fold, you save those out of fold predictions. And you can, if we, maybe I'll go somewhere else. It'll be easier to show here. Here you go. Here's some more data sets. So I would save these OOF predictions. So I concatenated that. So this is the actual trained CSV data. And then I've added these two columns called fold and prediction. So these are my out of fold predictions. And these are really useful. So if you're ensembling models, you would use these predictions to train some sort of a other model to predict your final answer.
Mm.
Um, so I used all of these out of fold predictions, but the tricky bit was, so normally when you do this, you're supposed to use the same validation scheme. So you keep your folds the same. But the thing I was worried about, because I was changing my random seed, all of these folds are slightly different. So I was really scared about leakage. Um, so the cross-validation scheme that I lent towards was something called leave one out cross-validation. So because there's a small data set, only 2,800 samples, you could do leave one out cross-validation to try to build an ensemble model. So I used, the other thing I really like using for ensembling is linear models. If
Mhm.
you just use a linear model, it's really hard to overfit. If you use one thing, lots of people like using something like XGBoost and something like that for the ensembling. Um, I've never got it to work, but I'm not very good at ensembling. So that was one of the reasons I got into this competition, because I wanted to learn how to ensemble as well. Um, so I used this scikit-learn class, so called RidgeCV,
Mhm.
and it by default it does this efficient leave one out cross validation. And I don't know what, if you look in the code, it's like magic. It's really deep matrix math, but it does leave one out cross validation super fast. So that's what I did. I had all of my models. So I took all of these models that I trained in this spreadsheet, and then I ran the Ridge CV on there. And then Ridge CV gives you a little best score, which is actually mean squared error, which is exactly what we wanted to predict.
That makes
Um,
sense.
and then what I did is, let's say I had 300 models, whatever, and then I would run it again with every combination of 299 models, and see which if I removed one model, which one would improve my score the best. So I would iteratively keep removing models to whichever model was the worst. So keep pruning models until I got down to, and then I got down, let me see if I can get the notebook. So let's see. It might be easier to show you notebooks stacking. So here's all my models up here, all of these checkpoints.
I'm just trying to absorb the checkpoints.
Yeah, there's so many. Is this big
Yeah.
enough for you? Or shall I make it bigger?
This is fine.
Yeah, I'll make it a little bit bigger. So what I would do, here we go. So I'd start off with all of the models and calculate a CV score, and then I keep removing models, whichever one improved my CV score the most. And you can see like the RMSE in this column keeps dropping, and then this is the size of all of the models together. Now, obviously, I can't submit a model with 1 terabyte on
Yeah.
Kaggle, not in 3 hours runtime. So I
Yeah.
would keep going down until I found that I could probably run around about 170 or 180 gigabytes worth of model weights in the 3-hour runtime. So this was the ensemble that I would use. So there would be about 38 models left in the bucket, and I would use that.
Gotcha.
And so that was my final ensemble. So I found that worked better than sort of starting with your best model and keep adding good ones, because I've thought that you want to get an ensemble of models that work well together, not lots of strong models. So there was something I found digging around. Where is it? There is this really interesting approach. So this is from the Netflix Prize in 2009. So there's Michael Jara. He's still active on Kaggle, I think.
Yeah.
And they've got a really interesting ensemble approach where they just keep adding models, but not to make better individual models, make a good overall ensemble. So usually when you're ensembling Kaggle, you take your best models and average them. This approach is slightly different because, if you look at the actual cross-validation scores for some of these models, this model here, this Albert Large, is terrible. If I submitted
Yes.
that on the leaderboard, it would be terrible. But when combined with the other models, there was some sort of self-correction going on. So there was some strength that this was bringing that would correct the errors of the other models, which was interesting for me. It was the first time I've done that or ensembled in that way.
Isn't this also the base of a lot of boosted algorithms? Isn't that how they also combine models? I might be
Yeah,
wrong on this.
yeah. So yeah, it's really interesting. I definitely recommend having a look at this big chaos solution to the Netflix Grand Prize. This is in 2009, but it's a really interesting read. So I actually did use their ensemble model. So I found a implementation of that where you actually use your cross-validation scores to estimate the weights as well. And that one had even better private leaderboard score, but I wasn't so confident in the cross-validation score, which is why I didn't select that as my final submission. I was more confident in the CV score from this, which is what my final submission was in the end.
Gotcha. So that is the complete picture of the money money
Yeah,
prize.
yeah,
Money bowl, if I may.
yeah. And I think normally in other competitions, say like some of the image competitions, it takes too long to train 38 models, right? So you don't have that many to ensemble. But in this competition, I was able to train that many models because the data set was small, which is probably one of the reasons that helped me get a solo gold. If it was a bigger data set, and if the models took longer to train, then you would probably struggle getting into solo. It's got, in fact, a lot of the top positions were solo as well, which is unusual these days for Kaggle. So
Yeah,
yeah.
that's awesome. I really wanted to dive into this because, like, I don't think, at least in chai time data science, I wasn't able to understand these nitty gritty details. Like, we just found out one trick, and
Mhm.
also, at least as a community, we were able to understand how did you pick that ensemble, because ensemble just sounds like you're just averaging all of these CSV files, but no, there's more to that. There's like a
Yeah, yeah,
method to the madness in a way,
yeah.
and we got to learn all of that.
Yeah, it has to be guided by cross validation. It's so easy to find have any sort of leakage that goes on. Otherwise, you don't, without cross validation, you're blind.
Absolutely. All right, I think we can move on to the community, Amy. I'll just take a peek. I don't see any questions. Not in the Zoom chat answered. Please feel free to ask any questions. I'd left over the last 15 minutes. We might go over a little, but just for community asking questions. Awesome.
I could show you some
I
other stuff about weights and biases. There was one thing that I've been using weights and biases for since March now, so there's tons of stuff I don't know about it. But
Mhm.
one thing that worked really well for me is this thing. I don't know if you've seen this before, but when you do a run on weights and biases, it it stores the Git state. So when you're doing like loads of experiments
Yeah,
and you change something, even if it's something that you've not committed, it stores that. So if you click on this, which this blows my mind, but it's actually a branch of what your code looked like at the time, even if you never committed it. So if you change something, it's like, oh, that worked, but I've forgotten what it was because I forgot to write it down. That was pretty amazing. So that's really cool. I really enjoy that about weights and biases.
I'm just like finding out after joining, but like there's so many details to all of
Oh,
all of the
it's amazing.
things.
Yeah.
Yeah.
There's like I'm still learning all of this stuff. Yeah, I need to spend more time really getting into like lots of these sort of features. It's great. I really enjoy it.
That's
The other
great to
thing is
hear.
like I used to use TensorBoard a lot, and when you like you get addicted to it and you're watching your loss curves going down, and then you're like, oh God, it's 1 o'clock at night. I've got work tomorrow. What am I doing with my life? I'm just watching loss curves. But like weights and bias is great because if you're on a train or something going to work and you can just check on your phone, it's like, yeah, my model's still going. I really enjoy that aspect of it.
That's that's lovely to hear. Thanks for the shout out. Awesome. So I don't see any question, but I'll squeeze in mine shamelessly because I'm hosting the event. I'm just curious. This is a random series of questions that I always end up asking towards the end. What's your favorite competition of one that you've competed in and one that you were just like reading or studying about on Kaggle?
Yeah, I'll stop sharing. I really liked the predicting molecular properties one. That was really cool. Because a lot of the final solutions, they're all very different. And also it's that sort of really studying something and getting creative with how you generate features and stuff like that, rather than just brute forcing it by throwing it deep neural nets and stuff. I really enjoyed that competition. Yeah, and I learned a lot from that about things like chemistry and stuff like that.
Do you have a favorite algorithm for any set of problem that you always start with?
Favorite algorithm? Not really. I like whatever one works the best, really. I'm a massive advocate for just for using linear models.
Hmm.
Uh, whenever I start a project, I'd always start with either logistic regression or linear regression, mostly because it helps you understand. First of all, you got a baseline model, and they're really explainable as well. It's really hard. It's really easy to show that to someone, and they'll understand it straight away. So I'm a big fan of linear models.
Also, that's like really hard to implement in practice. Also, like you're always so tempted to. I would just be tempted to try Roberta. Now that you've mentioned it works well, whenever I think of NLP, oh, Roberta, that's
Yeah.
what I would want to try. Okay, this is a hard one. Some people find it hard. Do you have a favorite game? You can pick two, so one of all
Oh,
time and one from the current set that you're playing.
so it's been a while since I actually played computer games, but I used to like all the sort of racing games and stuff. Um, and I really used to enjoy. I really enjoyed like the Final Fantasy games, so Final Fantasy 7. Been meaning to get the remake of it, but I've never got around to it. I never had time to get around to it, but it looks amazing, the remake.
Jeeba mentioned the same one. Awesome. Last question. Any special trick that you could share with us? Any secret to Kaggle that you've picked up over these years? You can say no.
I
You can keep the secret to yourself also.
I can't give you all the secrets, can I? No, I think the thing that's worked best for me is just the mantra of test as many ideas in the shortest amount of time. If you can do that, if you write your code so that you're able to do that, you'll start to see your leaderboard position really improve. Is really powerful, that approach of approaching machine learning.
That's again, I want to point out that's incredibly hard to implement in practice. Before we end, I would quickly point out Anjum's profile on Kaggle. It's Datasaurus. You can find him there, and you can also find the reason why it's called. So if you go over to this kernel, you can see the plot, and that's how his profile picture came about. He's also on LinkedIn, and he's Anjum Sayed on Twitter as well. Simply at Anjum Sayed. Anything else that I missed, Anjum?
No, that's it. This has been super fun. I really enjoyed it. Thank you so much for having me on.
Likewise, thanks so much. I see one question, so let's try to squeeze that in. Real quick, how do you approach ED and data visualization in NLP? How do you break down the task?
Oh, so how do I do it? I look at someone else's notebook. No, yeah, EDA with NLP is really tough. It's not like you can plot one feature against the other. You have to generate those features and then plot them against each other. So yeah, I'd recommend having a look at some of the other notebooks in this competition, because people much better than me at EDA had done some really beautiful plots. But I think the common theme is you're going to have to take the text and then generate features from them and then try to do your analysis on those features, which is kind of a two-step process. It's not like you start with a CSV file full of numbers which you can start plotting. So there's that additional step, but it's tricky. Yeah, really understanding NLP data and exploring it is tough. And sometimes the best way is just to sit there and read it.
Yeah, I'm looking at the chai competition, and I really wish like I had someone. I can speak Hindi, but I can't speak the other language, Tamil, and I'm just trying to find a teammate who can. So
Yeah,
I
yeah.
echo with you there.
Yeah, that one
Awesome.
looks like a tough competition. Maybe I'll jump into it, but yeah, it sounds
I'll,
interesting.
we all will see on the leaderboard. I'll probably be at the bottom. You'll be on the top, but I look forward to seeing you there. I don't want to go much over the time since we've already gone overboard. But Anjum, I just wanted to say thank you so much, and it was really an honor learning about your solution. And thanks for sharing your journey with us.
No, thank you. It's been an honor. Thanks very much.